Hi everyone, I'm Lisa Ackerman. I am so excited today. I'm here with Dr. Theo. Dr. Theo, thank you for joining me today.
It's a real pleasure to be with you again.
Thank you. And for the audience, just tell me briefly a little bit about yourself.
Well, I was born in Greece. I came to the States in 1968 as an undergraduate at Yale. I stayed at Yale for the longest time ever. I have 5 degrees from Yale. Then I went to Tufts University in Boston, did training in internal medicine, have been there ever since. And my work has been on what we called neuroinflammation. And for the last 5 years or so, I had the pleasure, if I can say that, to also investigate aspects of autism.
Excellent. Well, you and I have been friends a long time, and you very much underplayed yourself. You're an amazing researcher. We're grateful for you. But we only have a brief amount of time, and I really want to just dive right in. Can you tell me, what is inflammation really? I mean, where does it start? What is it?
So inflammation is part of what we call the immune system, but it's the response of the body to some either internal or external trigger. And usually the initial response is very helpful, very protective. But very often it goes overboard, and then it becomes destructive to the body, various tissues, various organs, and that's when we really worry. So most of the time, again, the initial response gets out of whack, and then we have to deal with what we call an auto-inflammatory response that is really destructive to the body.
Thank you. Okay, great. So when you talk about persistent inflammation, where is this inflammation usually found in people with autism?
So as with any other group of people, people with autism could also have other, we call it comorbidities, or other conditions that might occur at the same time. So if a child were to have eczema or asthma or inflammation in the gut, then the inflammation would be there, obviously. But what triggered us and a few other colleagues before us is that indicators of inflammation were present in the blood as well as in certain parts of the brain of children who had died, and the families, God bless them, donated their brains for study. So in those children, and they appear to be about 60% of the children in the 3 studies that have been published, one was ours, others were not, was actually in the area of the brain that regulates emotions and fear, which is called amygdala.
Interesting. So in the population for autism, what are the most common ways inflammation can be caused or started?
So inflammation could be absolutely against any pathogen. It could be viruses, it could be bacteria, it could be parasites. Some may enter the brain as the full pathogen, like sometimes you get meningitis, for instance.
Right.
Sometimes it might be only toxins that are released. So you might have an infection, let's say, in the intestine, and it will get into the brain. The tricky part is that the brain is protective by what we call the blood-brain barrier, which is not really a wall, it's just 2 sets of cells that protect it. But around those cells that protect the brain is also that type of cell that is also involved in allergies, that is called the Mast, M-A-S-T cell, and that's why we got involved. So if the mast cell gets activated, then it will release molecules that make the blood-brain barrier disrupted, leaky. So now, either toxins or full pathogens from the blood, and especially from the nose, because the nose communicates directly with the brain up the track of the olfactory nerve, will activate basically what is found in the brain exactly behind the beginning of your nose, which is what we call the basal ganglia. That's the thalamus, hypothalamus, and amygdala that regulate your whole body, homeostasis, and especially emotions and fear. And we feel that that inflammation is like shortening the electrical wires or getting the spark plugs rusty in that area, right, and the connections just don't function properly.
Wow, that's so. Are there any anti-inflammatory drugs that are effective and can be used?
So we hear the word anti-inflammatory all the time, but we really don't have very good anti-inflammatory drugs. So the most commonly known group is what we call steroids, like cortisone. Same cortisone you put in your skin. But we don't want to give that to children because they have a lot of side effects and they can keep their growth basically, very low, plus they can cause depression and other problems. Then we have a set of molecules or drugs only for a specific part of the inflammation. That's like the aspirin, Motrin, ibuprofen.
Right.
They inhibit only what we call prostaglandins. You see, in inflammation, we have 3 different cell types involved: polymorphonuclear cells, macrophages, and mast cells, and close to 50 different so-called cytokines.
Right.
3 of those are interleukin-1, interleukin-6, and TNF. All of those have been found high, both in the blood as well as parts of the brain of certain children with autism. So the prostaglandins, which are inhibited by aspirin and ibuprofen, have not been involved at all in autism. So that would be literally useless, even though we call it anti-inflammatory, except in the case of PANS pandas, where we find that about 50% of the children do have high prostaglandin D, which is a bad prostaglandin, and in those children, aspirin-like drugs will be helpful. Then there are 2 antibiotics, and we think of them only as antibiotics, but both doxycycline, which belongs to the tetracyclines, and azithromycin, which is very similar to erythromycin, also have anti-inflammatory effects, and they're very commonly used in children with PANS pandas. And then we're left with drugs which we have never given so far to children that block only specific cytokines. So there's a drug only for interleukin-6. There's a drug only for TNF. They're used very commonly for asthma or for arthritis or for psoriasis, but no study have been done so far in children with autism. They're injectable and they can make infections worse. So I would worry very much for a PANS child, because their likelihood of getting sick with some infection will become worse. And then we have some natural molecules that we will talk a little later about.
Great. And again, all of the stuff we're talking about, we have topics in the conference so people can watch on everything. And we're so grateful you're here to kind of demystify some of this for us. So, but talking about some supplements, I mean, I'm afraid of some of the drugs you just mentioned, even though I have an older son now, but for younger kids, what are some supplements people can do that maybe would help with inflammation?
Right. So we've known for many, many years that certain molecules called flavonoids do have antioxidant and anti-inflammatory actions. However, there are about 3,000 flavonoids in nature. That's what makes actually the leaves change in color in the Northeast. They're very protective as well. So they're anti-inflammatory and cytoprotective. Over the years, a group that includes mostly quercetin and luteolin most recently have been studied extensively. So there's some good and some bad things about all of these molecules. So the good part is that they are very potent anti-inflammatory. And we published just in the last 2 years, 3 papers in the Proceedings of the National Academy of Sciences that luteolin and a cousin of it called methoxyluteolin can block inflammation, and specifically they can block the cells in the brain that cause inflammation, because the brain does not have immune cells, it has microglia. So it is the microglia that defend the brain. If circulating white blood cells get into the brain, that's a no-no. That will cause, for instance, multiple sclerosis. It can cause encephalitis. We don't want that to happen. Okay? So now, the next good thing is that we and others have shown that these molecules are also anti-allergic. They inhibit mast cells, and to the extent that mast cells play a role, now you have 3 birds with 1 stone. And finally, there are other colleagues who showed that they can actually protect brain cells from the action of the inflammatory cytokines. So now you have 4 birds with 1 stone. Now, what's the downside? The downside is that less than 10% in the powder form that are usually sold can be absorbed from the gut. And what happens is, some of my colleagues will say, oh, I'll give you like 3 grams a day, 3,000 milligrams a day. What happens is, nothing horrible will happen except that it accumulates in the intestine and it shuts down your bioflora in the gut. And we talk about the bioflora, but we don't talk what happens if these flavonoids accumulate in the gut because they cannot be absorbed. Okay? Now, the difference between quercetin and luteolin is very slight, like 5% difference in structure. But that 5% allows luteolin to enter the brain, while quercetin is much harder to get into the brain. So it is the makeup of the molecule that makes it more likely to get into the brain. So what we've tried to solve the problem to some extent is, number one, how do we actually get them to be better absorbed? And if you mix them up with any oil, basically they get better absorbed. So we tested a whole bunch of oils, and it turned out that olive oil was very good. After all, it's Mediterranean, diet, and I'm Greek. But the olive seed oil, after you squeeze the flesh and you get the olive oil, you're left with the skin and the pit and some leaves, etc. If you squeeze those, you get a thicker oil. We use it for salad dressing in Greece, Italy, etc. So it's called olive pomace oil or olive seed oil. That's cheaper, and it's also in itself rich in anti-flavonoid molecules. So we mix basically either luteolin by itself in what is called pure luteolin, or together with quercetin in a ratio so that luteolin is more than quercetin. So quercetin can still act, but allows the luteolin to get into the brain. And that increases the absorption about 4 times. It's not the best, and maybe at the very end we'll talk what we might be able to do, but that's basically the best. And there will be a paper of mine will be published within the month in a very good journal, and it is called Luteolin Supplements. Not everything that glitters is gold, pretty much. And I have a discussion and a table of all the available luteolin supplements and their purity or lack thereof, the source or lack thereof, the amount. Sometimes they don't say amount. So what has happened is, when we came out with Neuroprotect, I don't know, 6, 7 years ago, there was no luteolin in the market other than Neuroprotect. Now there are about 9 different supplements, and most of them say proprietary blend. They don't tell you how much luteolin there's there. And what they do is, because I analyzed a whole bunch of them, they mix them up with rutin, R-U-T-I-N. Rutin is found as quercetin in nature, but it's a very large molecule. It doesn't get absorbed at all. Its effect is very slight, but it is dirt cheap. So that's what they do. So they put 90% or 50% rutin and a little bit of luteolin, and an unassuming consumer thinks that they're getting the best, and they're not.
It's always about quality. I agree. So, you talked about some of these ingredients, and for some of our listeners today, we'll type out those ingredients so they know how they're spelled. What do you do to address phenol intolerance? Because that was an issue with my son when he was younger.
Right. So we didn't even know. When I started out, I had no idea what that really is. But as it turns out, most of the, not only children, but adults that cannot tolerate berries, strawberries, blueberries, grape seeds, chocolate, some people even Tylenol, because it's phenolic, they get actually hyper. They get wired, some people have different terms for that.
Yeah.
That, whenever it happens, by the way, it's very temporary. So, if you get hyper, whether you take a product or some food, usually in a day or two, tops 3-4 days, it will be gone. So it's not like your whole personality has changed.
But 3 or 4 days and a kid of autism.
It could be, I agree 100%. 100%. So 3 things one can do. And by the way, the flavonoids are phenolic themselves. That's why I worry. But they're different phenolic weight, if you wish. So if on the molecules they sound like a water would be 2 hydrogens and an oxygen. If you drop 1 hydrogen, that's called a hydroxyl group. So the more hydroxyl groups you have, the more phenolic you are. So for instance, pycnogenol, which is found in grapes, etc., has 15 phenolic groups. Quercetin has 5, luteolin has 4, etc. So the fewer phenolic groups, the better off you are, obviously. Then one can check either by asking, of course, the family or a child, if the child is conversant, etc., or you can do some genetic testing And now more and more, we should be doing genetic testing. So the three enzymes, one is called COMT, the other is called MAO, and the other is called PST. I'm not going to bother now with giving you the whole names, but those are the ones that break down phenols. So if someone does any gene analysis, whether it's 23andMe, or you go to some other group or doctor's data, etc., if you have mutations, usually we call them either fast metabolizers or slow metabolizers. So if you're a slow metabolizer, you cannot break those things down. So therefore, either you avoid them, or you take the least phenolic group. That's why we made pure lut. So only luteolin, no rutin, no quercetin. Or you add some enzyme, and Houston enzymes is something they called low phenol, LO, not LOW, low phenol, that breaks down the phenols. But the problem is if you break down the phenols, that's part of the activity of the molecules. So if you break them all down, then you're not getting any benefit. So it's always a little bit of a balance. My advice always is for any flavonoid or any phenolic compound, and curcumin is phenolic too.
Right.
Start very low, and that as you tolerate it, you increase it up to the point that you can tolerate it. Duration of time is very important for me, not the amount.
Right.
Because if the amount is too much and you give up, then you've lost the chance to actually get some benefit.
Right. And it's just so important to go start low and slow with your doctor. I agree, totally. So I want to get two more questions in because I could spend the whole day with you, but we have two more to hit.
Thank you. It's a pleasure.
It is. So are there any published papers on the Algonaut and this product?
Yeah. So there are two published open label study. And by open label, I'm sure you realize that there isn't a placebo at the same time. And in all honesty, and I teach this at the university, for diseases that are as complicated as autism, placebo almost doesn't make sense.
Right.
Because there's so many variations within autism and so many subgroups and then comorbidities. You cannot find a quote unquote pure, totally homogeneous population to do the studies. Right. In any event, one study was done in Greece that was about 9 years ago. I was not an author, so it wouldn't be any conflict of interest. So they gave Neuroprotect for 4 months. And basically, just to break it down, 1/3 of the children did very well within 4 months. 1/3 gained some and they didn't lose it. And 1/3 just there was nothing at all. And then was a subsequent study done, in which case they sent us blood from the children blindly. And I am an author of that study, but I didn't know what the children were. And we identified that in 1/3 of the children, the cytokines we were talking about earlier were very high. And when we sent the results back to the original authors to find out what the severity of the symptoms were, those were the children that were actually the worst, but those were the children that died better after they took the Neuroprotect. So I have no idea whether it's Neuroprotect or some other intervention. We do, or we can identify about 50% of the children that might be more likely to respond with some benefit. Even if you were to go blind, at the end of the day, you might say, I got no benefit, except that you'll get frustrated.
Agreed.
And I think that the pandas and past children, because they have inflammation, are the ones that might do considerably better given what I just discussed.
Interesting. Well, like I said, I'm going to leave one more question with you because I would be remiss if I didn't ask you, what are you working on in future products for Algonaut?
So there's a unfortunate and a fortunate side. The unfortunate side is that in spite of all my efforts with NIH and foundations and personal families, I couldn't get enough money, so they shut my lab down. So there's no basic science done right now, even though, as I told you, we published 3 papers in the Proceedings of the National Academy of Sciences, a very good journal, as you know, just in the last year and a half. Now, the good part is we're struggling through Algonaut to do 2 things, and I think both will be forthcoming maybe by the end of the academic year, not the calendar year. So originally I was trying very hard to make a nasal spray because it will get into the brain directly, and a child could be asleep and we can still give it, etc. No large company has shown any interest at all. So we are trying to do it now ourselves. It might not be the most sophisticated way of doing it, but we will. And we're trying very hard to improve on the gentle derm. As you know, flavonoids like quercetin and luteolin are yellow, so we couldn't make a skin lotion. However, the methyl luteolin that we identified doesn't have any color. So we made this gentle derm, as you know, which is very hydrating, but very good for irritated skin, etc. But a number of families have told us when they rub it basically on the temples, they get enough absorbed in the temporal vessels, and together with Neuroprotect, they do much better. And methoxyluteolin is even more potent than luteolin. So we're trying now, we've identified a company, we're trying to make a transdermal patch so that we might be able to put methoxyluteolin, and you can put it, at the back of a child that will not be able to reach it, hopefully to remove it, etc. You might get enough absorption through that.
Well, exciting work, and just really appreciate all that you do. And
thank you.
We've been friends a long time. I appreciate you. So thank you for joining us today.
I appreciate you letting me speak to you and all the families that are struggling, and God bless you all.
Oh, bless you. And for the families, we'll type out the terms that we use today, and we'll also link the talks so you can find more information. But thank you again. Thanks for joining me.
And by all means, they can, feel free to visit. It's a rather silly name, but it's www.mastcellmaster.com. It's our website. But all the publications are free on PDF format. And every lecture I've given within reason for the past so many years, it's up there as well. And there's some presentations in Greek for whoever might be.
All right. There. Maybe I'll go.
And I do have one presentation in Spanish as well. It was done in Peru some years ago, but it was translated and it's there.
Oh, well, thank you again, Dr. Theo. We appreciate you. Keep up with your good work. Bye-bye.
Thank you. Bye.